Descriptive Statistics. In this program, I'll use the credit card data set to demonstrate the descriptive statistical techniques that we're using in class. So we'll be examining the distributions of each of the variables, and we'll be examining relationships between two variables. So remember, that's going to require us to identify an independent variable and a dependent variable. In our credit card data set, the dependent variable is always the amount charged, or the amount charged category if we're working with grouped data. So instead of thinking about these activities as separate individual problems, we really want to see this as one analysis of the data set. So mainly we have two specific research goals or objectives. The first is simply to examine the distribution of each variable, okay, and to describe what we see. This is an important step because not only are we going to understand our sample a little bit better, but we'll eventually be able to determine if individual variables or the data set overall is really useful for making statistical inference or guesses about the entire population. So to get started, we're going to identify our variables and what type of data they are. So the income variable is quantitative, and the household size also is quantitative. The amount charged, also quantitative. And we have age, which is quantitative. And so what else do we have? Well, we have gender and ed level and marital status. And these are our categorical variables. So the method that we're going to use is going to vary. So let's look at the data and run the analysis and see what we could do to report the results. So looking at the data, let's start with the income variable, which is variable number 1. So we just want to examine the distribution, and it is a quantitative variable. So we're going to specify variable number 1 in our quantitative variable input. Clicking on the Worksheet tab to see our results. We'll start with the histogram. The histogram here shows no strong skew, or we might even be able to say it's an approximately normal distribution. Checking our z-scores, we can see on our NQ plot that there's no strong skew. We see that also on the box plot. We see that there are no z-scores that are beyond 3, and that's our standard for classifying a data value, an income, as an outlier. We could also scroll to see that none of the z-scores are flagged as outliers. So having run our analysis, we can now report our results. We're just describing the distribution of cardholder incomes, and we could say that the mean is 133.872. Remember, that's in thousands, as is the standard deviation of 46.408. We could also comment on the shape of the distribution and say specifically that there's no strong skew, or we might even be able to say this is approximately normal. And we definitely would like to note for our sample of n equals 109 that there are no outliers. You can see I've also copied the histogram from our Excel tool, and I've kind of shrunk it down and labeled it Figure 1. So this is providing a visual showing that distribution is outlier free and has no strong skew. So let's try another quantitative variable. This time I'll work with the amount charged. So variable number 3 is our amount charged, and it is quantitative. So we're going to input the number 3 in our quantitative input tool. And we'll go to our results. So we see our mean and our standard deviation. It would even be appropriate for us to maybe copy this part of the tool and then go back to our Word document, and simply here we could paste our table. But when I paste from a live Excel document to an open Word document, Office wants to keep these two files linked. So when I paste, it's important that we want to choose Paste as Picture, so that if we were to go back to Excel and change to a different variable, going back to income, we don't want these statistics for amount charged to change. And this happens a lot when, not so much when we're pasting a table, but it happens a lot when we're pasting charts, like our histogram. So looking at our histogram for amount charged, we could move that one over just like we did for income by copying it and pasting. Now, there's two ways that we could have done this. We could go to the paste options and select paste as picture to freeze that chart as a picture. Or we could simply paste special as a picture. And adjust our size. And maybe even add a label. Charts and graphs are usually just called figures, and tables are called tables. So I have now Table 1, Figure 1, and Figure 2. Now, if we did our job right, we should be able to go back to our Excel document and change our variable to something like age, which is number 6. Now that chart changed, but in our Word document, we could see neither chart has changed. So once we understand how to use the Excel tool and what method or approach we're taking to examine the distributions of our quantitative variables, we could be very efficient in reporting the results. So with just a single table and briefly, very quickly, efficiently copying and pasting my table from the histogram worksheet, I could see the descriptive statistics, the mean, the median, standard deviation, as well as the range. Now, I'm not commenting specifically on every one saying it's approximately normal or no strong skew or no outliers, because I chose to include the histograms, which are showing that for us. And so with the histogram, we could see that income, amount charged, and age, none of those variables have any strong skew or any clear outliers. However, the household size variable, as we would expect, is skewed to the right. And we could see that on the histogram, and so I've added that here. However, the skew is not strong enough to produce any clear outliers. And so the last thing I'm going to add to complete my descriptive analysis of these 4 quantitative variables is just a note indicating that there are no outliers in our sample of 109. So using shape, center, and spread, our histograms, our z-scores to check for outliers, our mean, median, standard deviation, all of those descriptive statistics are great for quantitative data, but categorical data, we have a different way of doing the descriptive analysis because the data type is different. So here we have table 2 set up, and we would like some descriptive analysis for these 3 categorical variables: gender, marital status, and education level. So very simply, we could use our Excel tool to create the frequency distribution table, and we could add those results to our report. So now that we are getting more comfortable using our Excel tool, we could do the descriptive analysis for our 3 categorical variables rather quickly. So we know that we simply input the variable number, such as variable number 4, and our category labels, which are M and F. The worksheet tab categorical will show us that our sample of n equals 109 has 45% men and 55% women. I could very simply add that to our report. So the frequency distribution is what we're after for a categorical variable, and we could very quickly obtain the frequency distributions using our Excel tool. BA, M, and D, our 3 categories of education level, and 61%, 23%, and 17% respectively is what we see. And now we've added our frequency distribution for education level. And we could repeat this for marital status. Optionally, just like with our quantitative data, we could use some visuals. And we could choose either the bar graph or the pie chart. Visuals are nice, but they are certainly optional. I'm going to take the pie chart for education level. This would be figure 5, education level. And now we've pasted, but remember, we want that to be a picture so that it does not stay linked to Excel. And we could shrink it down a little so that it doesn't take up so much space. And this is adjustable just like any other picture would be adjustable until we get it the way that we like. But the important thing is that we should now be able to go back to our Excel tool and produce another pie chart, such as for gender. And when putting this one into our Word document, we don't want the education level to change, and it hasn't, because we pasted it as a picture. And we could continue this just as we have for our quantitative data. So our report is taking shape, and we've used the Excel tool to examine the distribution of all but one variable. We have one more to do. And then we'll be ready to move on to examining relationships. So let's look at that next. So far we have just examined the distributions, and we're developing a report that is taking shape in terms of our descriptive analysis. But we'd like to move on now to our second objective, and that was to examine the relationships between these two variables. So we're working with not real estate, that's what we're doing with our case, but here we're looking at the relationship between cardholder demographics and the amount charged. Okay, so we have the demographics: income, household size, we also have age, gender, marital status, and we have education level. These are our independent variables, and we would like to know what effect, if any, or what relationship, in other words, these cardholder demographics may have with the amount charged. So this is our dependent variable, and probably the most important variable for any study of credit cards, right? Because that's what's generating the revenue. So what we want to know is if there is any relationship between who a cardholder is demographically and the amount that they spend. So we need to make some choices now about how we're going to examine these relationships. And again, this is going to depend upon the data type. Let's start with our categorical independent variables: gender, marital status, and education level. So here we're going to use our group mean technique, and we're going to create two groups of amount charged, for the men, for the women. For marital status, we have three categories: single, married, and divorced, and we'll create three different distributions of amount charged to see if there's any significant difference or any apparent difference between the means. We'll do the same for the three categories of education level. So if the independent variable is categorical, such as gender, and if the dependent variable is quantitative, we could, using the data as is, use our group mean technique to examine the relationship. So to do our group mean analysis, we just need to group the amount charged data by demographic category. So we're going to use our Excel tool, specifying our dependent variable is quantitative, and then all we need here is a variable number, such as number 4 for gender. Our worksheet tab grouping does the rest. We just need now to specify the grouping category, such as M. And you can see again, we very simply can copy our table. Here we have no strong skew, no clear outliers according to the z-scores. So going back to our Word document, we could paste as a picture the descriptive statistics for men. And we can repeat this for women. So no strong skew, no clear outliers according to the z-score. I can capture my descriptive statistics and paste them into my report. Now, later I could explain what the relationship is by discussing the difference between these two sample means. So specifically, 44.70.82 minus 36.95 and 18 cents would give me a sample mean difference between men and women. This is really the main purpose of our group mean analysis, to consider what effect gender has on spending. So continuing my group mean analysis, the dependent variable, number 3, doesn't change. What does change is my grouping variable, or my independent variable. So we already did gender. Just changing to variable number 8, which is marital status, now we're telling the Excel tool to group the amount charged data by the category of marital status. So single, married, divorced, and we get a table of descriptive statistics and our sample size just for that category. And I did these for all of the categories very quickly and just copied that table. Now again, we would want to comment on any strong skew or any outliers. In our data, grouping by category did not show any. So what do the descriptive statistics show? Because that's what we're after, right, is the effect that these independent variables have on our dependent variable. So just generally, we could see that women spent on average more than men. For marital status, the married group spends notably more on average than the single group, but the married and divorced groups spend on average roughly the same. For education level, we could see that there's virtually no difference in mean spending between the master's level and the doctoral level cardholders, and they both spend on average a little bit more than the bachelor's level. So these are the effects that we're trying to note through our descriptive group mean analysis. So we're off to a good start examining relationships between the cardholder demographics, our independent variables, and how much they spend on the credit card, which is dependent. And we used the group mean analysis previously because our independent variables, gender, marital status, and education level, those are categorical, and our dependent variable amount charged, quantitative. Now let's look at the quantitative independent variables, or our quantitative demographics, income, age, and household size, to examine the relationship between income, age, and household size with the amount charged, or in other words, what effect does income have on spending? What effect does age have on spending? And household size on spending? We would need to use correlation and regression analysis. So let's look at our Excel tool. So here we are at the Excel tool, and we'll start with income. Income, remember, is variable number 1, and that's going to be our independent variable. Our dependent variable, as always, is the amount charged. Regression and the group mean technique, both of these require a quantitative form of the dependent variable. So we're just going to use those amounts, the raw data, variable number 3. Okay, so our regression results are shown. So what can we report? Well, remember, when we examine the relationship between two quantitative variables, we want to comment on the form, the direction, and the strength of the linear relationship. So here we could see that there is a linear relationship, it's positive, and it's moderately strong. We could see that correlation coefficient R is 0.6249, and that is a moderately strong to strong positive correlation. So we could report these results. We could add our visuals optionally. There are only 3, so it wouldn't be too hard, to our report. Let's continue this correlation and regression analysis using our quantitative independent variables. And again, we're using regression because both the independent and dependent variable are quantitative. So we've already looked at income. I've already run the age. And now let's look carefully at the household size. Household size can be a little bit confusing at first because, as we can see, the scatter plot looks a little peculiar. And this is because although household size is a quantitative variable, it's what we call a discrete variable. In other words, we have no values between 1 and 2, no values between 2 and 3, and so forth. And we see that on our scatter plot. But nevertheless, we can see that there is also a very strong positive linear relationship. Our correlation coefficient R shows that at 0.7528. So adding this information to our report is very simple. Income, we've already noted the moderately strong linear relationship, and our correlation coefficient. We did the same for age and household size. And we could either say here in the table that there are no regression outliers, or we could show that, or sometimes both. I've added the 3 scatter plots. It's very simple to do. Note also here, it's kind of interesting that the relationship between income and amount charged and age and amount charged, they're very, very similar. And this would lead us to believe that income and age themselves are highly correlated. We could see that they have very, very similar distributions. This is because age and income have a strong correlation. Now there is one more descriptive technique that we have for examining relationships, and that is our cross-tabulation. Cross-tabulation requires that both the independent variable and the dependent variable are in categories. So we have 3 independent variables that are already in categories: gender, ed level, and marital status. But our dependent variable, amount charged, is quantitative. So to cross-tabulate, we first have to group the amount charged data, and we've done that here in variable 7, creating 3 categories of spending, either low, mid, or high. So we could make 3 crosstabs using gender and variable 7, ed level and variable 7, and finally marital status and variable 7. If we wanted to, we could similarly group income into categories. We could group household size into categories. We can group age into categories and make 3 more crosstabs if we wanted to do that. We'll just stick with the 3 that are already in categories: gender, ed level, and marital status. So our crosstab tool requires us to specify an independent variable, but because it's always categorical, we need to also specify those category labels. Our dependent variable for this analysis is always the amount charged. Because we're cross-tabulating, we're using the grouped version of amount charged: low, mid, and high. So going to our crosstab results, we could see we have 4 different tables. Well, the crosstab itself is up here. So our row variable, or our independent variable on this table, our row variable is gender, and we could see our 49 men and our 60 women. And our column variable is the spending category. Now, the best way to show the effect that the gender category has on a spending category is by using a conditional distribution, or visually using the clustered bar graph, which is just the picture of our conditional distribution. Now, we have 2 possibilities column conditional distribution. In other words, we're calculating everything out of the column totals. Or the row conditional distribution, calculating these conditional distributions out of the row totals. We need to know where our independent variable is. And for our Excel tool, the independent variable is always the row variable, if we set it up correctly. So it's the row conditional distribution that's helpful for us here. In other words, if we consider only the men, what's the frequency distribution of spending category? And if we consider only the women, what's the frequency distribution of spending category? And the clustered bar graph shows that visually. So this is a very simple analysis because I can simply copy and paste into my Word document my conditional distributions. And again, we would like to paste as a picture. And that's one. Now we have two more to do, but we could also take, with our conditional distribution, our clustered bar graph. And remember, we don't want to keep this linked to the data. We want to paste it as a picture. And there we have it. So what does the crosstab analysis show about the relationship between gender and spending category? Well, we're looking for differences. Here we could see in the low category, if you're a man, you're much more likely than if you're a woman to spend in the low category. We could see in the mid category, gender has very little effect. In other words, the percentage of men and the percentage of women spending in the mid category are both pretty close to 50%. However, in the high category, if you're a woman, you're more than 4 times as likely as if you were a man to spend in that high category. So it's these percentage differences within the individual categories that give us a very different view than we saw, for example, with the group means. With the group means, we just know the women spent more than the men, and we could even say how much more on average. The crosstab gives us a little something extra because we can see that among about half of the men and half of the women, both of those would spend in the mid category. Okay, so not only do the women spend a little bit more than the men on average, and it could be a significant difference on average, but we see that that effect is strongest among the low spenders and among the high spenders. So we can see the effect that gender has on spending category. And if we simply continue to use our Excel tool, we could look at the spending category distribution by education level. Here we could see that education level does not have a particularly strong effect on spending category, certainly not as strong of an effect as we saw gender have. And we can tell that because of the differences. So while there are some differences, nothing really stands out. The biggest difference we see on the clustered bar graph is here in the mid category. Some difference here in the high category as well, but incremental changes as ed level changes, but nothing is nearly as big of a difference, as clear of a difference as we see here for gender. Marital status can also be cross-tabulated with spending category. Here we do see some notable differences. If you're single, you are much more likely to spend in the low category, as compared to the marrieds and the divorced. You can also see that there's very little effect in the mid category. In other words, the bars are about the same. However, in the high category, it looks like only one of the or two of the cardholders spent in that high category, whereas everybody else was either married or divorced. The last thing that we can do is to try to capture some of the results from our analysis. And we could summarize that in a section that we call results. For example, we could comment on the average spending, the average income, the average age, household size of a cardholder in the sample. We could also comment on the frequency distributions of categories such as male, female, and so forth. In terms of the relationships, we saw that the women spent more than the men. We could state precisely how much as a result. We saw that the BAs spent less than the masters and the doctoral levels. We also saw that the singles on average spent less than the marrieds and the divorced, but the M's and the D's spend roughly the same on average, just as the master's level and doctoral level ed levels spend on average about the same. In terms of regression, we could comment that there is a positive association between income, household size, and age on the amount charged. And in particular, household size has a very strong linear relationship. And finally, through our crosstab analysis, we saw that the differences in those percentages for low spending, mid, and high when we consider the independent variable categories. So all of these results could be summarized very simply in a couple of paragraphs, and that would complete our analysis. This concludes the program Descriptive Statistics, examining distributions and relationships in the credit card dataset.